Welcome. We have a new toy to play, new problem to solve, and with a weird heading, heat given to the system. Yeah, of course. And the problem says that an ideal monoatomic gas goes through a cycle. I'm keeping things simple, so I'm taking monoatomic gases again and again. And the problem is an ideal monoatomic gas goes through a cycle. I can see this cycle. Find the volume for which the heat given to the system is maximum in the cycle shown in the figure. As far as I can see the cycle, the first one, if I consider this the cycle, first part of the cycle, this is an isochoric section, and in this section P increases. So open the book of PV equals nRT. Since P increases, V remains constant, that means T increases. That means change in internal energy is positive, and according to the first law of thermodynamics, heat given to the system is equal to work done by equal to increase in internal energy of the system plus work done by the system, and here work done by the system is equal to 0. The process is isochoric, of course, so internal energy is increasing, we know for sure. That means heat is given to the system, but how much, we will find it later. In the inclined section, second section, inclined section, this thing, I'm calling it inclined section. Things are complex. I can't say anything for sure, so I'm not going to consider right now. But in this horizontal section, this is also a case where pressure is constant, isobaric process. Volume is decreasing, that means temperature is decreasing, that means change in internal energy is negative, and work done is also negative. So heat is taken out from the system. System is releasing heat. So we have to find the volume for which the heat given to the system is maximum. So it will be somewhere between first and the second processes, this vertical and inclined one. So we need to work now, and we are going to work. And first of all, I would like to find the heat given to the system in this process. And as far as first law of thermodynamics is concerned, that will be equal to increase in internal energy only, since the process is isochoric. That means I can write it here, n r by gamma minus 1 delta T, and only pressure and volume are given and delta T is not known, so I am going to use PV equals nRT, and T is changing, and that means I can write delta PV equals nR delta T. That's true. And here delta PV in this process is delta PV is what? Delta initial P, I would like to take P naught V naught. And finally, final thing, delta, final thing is 2 P naught V naught, right? 2 P naught V naught. And initial thing is final thing is 2 P naught V naught. So here the pressure is P naught V naught. Pressure is P naught and volume is V naught. So it's delta PV. What I'm doing here, delta PV is simply this, and that is equal to NR delta T, and this is simply P naught V naught. So I'm going to write down this heat in terms of gamma minus 1. Gamma for monoatomic gases is 5 by 3, and then this is 1 by 5 by 3 minus 1. That means 1 by 2 by 3, that will be 3 by 2 R. Why R? Because 1 by gamma minus 1 is 3 by 2, and NR delta T is simply P naught V naught. So this is the work done. Heat not work done. Work done is 0 here. This is the heat given to the system, and now we move towards the inclined section. And for this inclined section, want to use this section itself, and something is going to happen. So I would like to work as, I can take the pressure here as P and volume here as V. So I can write a pressure volume equation in general. So I want an expression in terms of pressure and volume. So I have taken these points. These things are important. These things are necessary, needed to work here. So this thing, I'm going to apply the similar triangle here, the idea of similar triangle, and I would like here 2P naught minus P divided by V minus P naught, that will be equal to 2P naught minus P naught divided by 2V naught minus V naught, that is P naught by V naught, so that I can get something like 2P naught V naught minus P naught equal to P naught V minus P naught V naught, and this gives me 3P naught V naught minus P naught V equals PV naught. I can write from here directly that I found V equals 3P naught minus P naught upon V naught. I need to divide by V naught equal to V. So this is the relation here for the inclined part. The pressure in terms of volume equation is P equals 3P naught minus P naught by V naught B. B is instantaneous volume somewhere. And now I need to find out, I'm willing to find Q in terms of V, because this is a requirement of the problem. You have to find out Q and V somehow. So Q is simply delta U plus W. So I am going to find out delta U first, and this is as usual, this is N 1 by gamma minus 1 is 3 by 2 R delta T, and this will be equal to 3 by 2 delta PV. PV is a new variable here. PV, since PV equals nRT, so nR delta T can always be written as delta PV. and delta P multiplied by B is a new variable here. So in these cases I would like to write 3 by 2 delta PV simply as in the final situation it was P multiplied by B simply minus initial condition. It is PV is 2P naught V naught. The multiplication of PV and the product of PV is simply 2P naught V naught. Yeah, that's right. And I have the expression for P as well. Yeah, P is here. So I can write delta U equals 3 by 2 P is 3 P naught minus P naught upon V naught V multiplied by V minus 2 P naught V naught. Oh, things are going to be bigger. I knew it. So in the next step I can write here 3 by 2 3 P naught V. I have to be careful. P naught V minus 3 by 2 is taken off, minus P naught upon V naught V square minus 2 P naught V naught. Yeah, that's fine. And now what? Now I can write it 9 by 2 P naught V minus 3 by 2 P naught upon V naught multiplied by V square minus 2 gets cancelled out, 3 P naught V naught. So this is the value of change in internal energy in this case. And one more thing is left, to find out the expression for work done. And work done, to find the work done, I can use the PV diagram. And I'm going to find out this area on the PV diagram, and that will give me the expression for work. And this is half P plus 2P naught, half P plus 2P naught multiplied by V minus V naught. It's a trapezium. And so I'm going to write down work done as half P plus 2P naught V minus V naught, right? And again we need to put the value of P here. So half, what is this P thing? 3 P naught minus P naught by V naught multiplied by P. So I'm going to write here in place of P simply 3 P naught minus P naught by V naught multiplied by V. Is it correct? Let's check again. 3 P naught minus P naught by, yes, it is correct, plus 2 P naught multiplied by V minus V naught. And that means I can write here half multiplied by 5 P naught minus P naught by V naught V, and this is multiplied by V minus V naught. So I would like one more step, and I would like it here 5 by 2, because I haven't calculated it before. I should have calculated this. So I could write the final result, but I have to solve it live. So this will be 5 by 2 P naught minus half P naught upon V naught multiplied by V minus V naught. And this will be simply 5 by 2 P naught V minus 5 by 2 P naught V naught minus half P naught by V naught V square plus half P naught V. Am I correct or not? Perhaps I'm correct. Yeah, it looks like I'm correct. V0 get cancelled out. Okay, so here 5 by 2 P0 V plus half P0 V, and that's going to be 3 P0 V minus 5 by 2 P0 V0 and minus half P0 upon V0 V square. And now, boy, this is the work done. And now we need to find the value of Q. And change in potential 9 by 2 P0 V0. Excuse me. That will be 9 by 2 P0 V0. If I make one mistake, oh, mistake has been done. And it is 9 by 2 P0 P only. That's right. Minus 3 by 2 P0 upon V0 V square minus 3 by 2 P0 by V0 V square and what? Minus 3 P0 V0 minus 3 P0 V0. Oh, that was the expression for change in potential. 9 by 2 P0 V minus 3 by 2 P0 upon V0 V square minus 3 P0 V0, right? And what was the expression for W? It is 3 P0 V. Okay. Minus 5 by 2 P0 V0 minus half P0 by V0 V square. And so I need to solve them. So first add them, these two terms, and this will be 2 minus 2 P0 upon V0 V square and plus P0 V term 9 by 2 3 and somewhere else. No, so it's going to be 15 by 2 P0 V, and these things minus 3 and 5 by 2, this needs to be added, these two terms, and it will be 11 by 2 P0 V0. So Q looks like, if I'm correct, Q looks like this. And you can see it looks like y equals minus ax square plus bx minus c. And you can see here I put a equals 2 P0 by P0, b equals 15 by 2 P0, and c is equal to 11 by 2 P0 V0. And I need to do what? It's a parabola. This type of parabola perhaps. So it first increases the value of Q. First increases and then started decreases. I don't need to know only the vertex of the parabola. So I can do one thing. I will differentiate it, find dy by dx, and that's going to be minus 2ax plus b. And then I can put dy by dx equal to 0, and that gives x equals b upon 2a. And I can put the values of b, that is 15 by 2 P0 divided by 2 multiplied by 2 P0 P0. And that's I get 15 by 8 or something. 15 by 8. Yes, the volume I get is 15 by 8 V0. And this is the required answer of this problem. So it was tedious. And this was a problem and I solved it. Thank you very much for watching.